All right, so now we have to deal with phase shift. We have to figure out what that means with relation to our graphs of sine and cosine. All right, so there's two different types of phase shift that we're going to be doing. One is a vertical phase shift and the other is a horizontal phase shift. So when you are looking at an equation, y equals sine x, and then you're adding a number or subtracting a number, but we're going to use d to represent that parameter, what that does is it shifts your graph up and down. And you've already had experience with that. It was a pretty basic shift that you were able to do right away. The more difficult type of phase shift is the left and right, or the horizontal phase shift. And that has to do with the angle. So what you're going to see is y equals the sine of something in parentheses has x minus a number. And this number that they should have here should be in radians. So something like pi over 2 or pi over 4 that you're going to be shifting. So that will shift your graph left and right. And what can happen is you can have both a vertical and a horizontal phase shift all in one equation. You can have amplitude and period change as well. Make it really complicated, right? All right, well, let's just take a look at a real basic one for a first example. We have y equals the sine of x minus pi over 4. So what you first have to figure out is which way is your graph going to be shifting. And so this number right here, the pi over 4, is telling us the amount that it shifts, and the negative sign means that we're going to go in the opposite direction. So that means instead of going to the left, we're going to go to the right. So it shifts pi over 4 radians to the right. Okay, so remember, anything that's in parentheses with x minus a number, and you're trying to pull out that number to shift, you always take the opposite of the sign. Okay, so first of all, what I'm going to do in red is I'm just going to graph the normal sine curve. So we have here up to 1, 0, -1, and there we go. I'm not going to actually draw in the curve. I'm just going to use these points, the basic points here, because these are the points, these 5 points, are all going to get shifted pi over 4 units, or pi over 4 radians, to the right. So that means this point here has to move pi over 4 radians. Well, if from 0 to pi over 2, we would need pi over 4 is half of that. So what we're going to end up doing is breaking up our axes into pi over 4s instead of pi over 2s. So now what you can see is that this point right here gets shifted to pi over 4. This point gets moved pi over 4 units over here to 3 pi over 4. This point is going to move to 5 pi over 4. This point down here is going to move to 7 pi over 4. And then this point is going to move somewhere over here. But technically we don't need to worry about that because it's past our restriction. We are graphing from 0 to 2 pi. So we can draw this in now. Oops. Ooh. Okay, there we go. Not my best, but whatever. Now what we do have to remember is that this part right here needs to go all the way to 0. So we need to continue this on. Even though we don't have a point over here to go towards, we know it's going down. We can stop right there. And in fact, we didn't even need to go all the way this far out, right? We could have stopped right here. So that's all we would need. So the points that I'm going to be looking for when I go to grade this, remember, are the points where we have the zeros, the maximums, and the minimums. So I would need to see all of these points on your axis. All right, so that doesn't seem too bad, right? Okay, well, you can imagine if it gets a little bit more complicated, maybe we add, say, 2 to this, say plus 2. That means all of these points after shifting to the right are going to move up 2 units as well. So it can get rather complicated. All right, let's take a look at a really complicated problem. Maybe. There we go. Okay. So take a look at this one. We have y equals 2 cosine of 2 times the quantity of x plus pi over 6. So we have an amplitude that's 2 instead of 1. We have a period change, and we have a phase shift. Luckily, we only have one phase shift and not both. Okay, so first of all, our period, since we have a 2 in front here, is going to be 2 pi divided by 2, so that's pi. And then the phase shift, we're going to move pi over 6 units, or radians, to the left. Okay, so first of all, since our period is pi, I'm going to put pi right there, and then that means I have to break up this space into 4 equal parts. So there's pi over 2, pi over 4, and 3 pi over 4. Okay, so what I'm going to do here, first of all, in red, I'm going to go ahead and graph my 2 cosine 2x without my shifting left or right. So it would look like that. Okay. I'm not going to actually draw in the curve right now, just because it might get too messy. But I do know that each of these 5 points are going to have to shift pi over 6 radians to the left. And so when you look at this increment, this is a pi over 4 increment. So how would you gauge where pi over 6, the measurement of pi over 6 radians, is from pi over 4 moving to the left? And the hard part about this is that the denominator that we have here, that we've broken up our first cycle of cosine, is a denominator of 4. And that is not a multiple of 6 or a factor of 6. So what we need to do is we need to come up with a least common denominator between 4 and 6. And that happens to be 12. And so that means that pi, from 0 all the way to pi, we actually have to break this up into 12 equal parts. And that sounds really crazy, I know. But it's not that bad. So if this has to get broken up into 12 parts, then up to here has to be 6 parts. So there's 3. That just means I have to put 2 pieces in here. So 2 pieces in between each of these, and there I have my 12 parts. So if this is 1 pi over 12, and this is 2 pi over 12, that's the distance from 0 to the second tick mark is represented by pi over 6 units. That means that this point is going to move 2 tick marks to the left, which is pi over 6 radians, right? So I know that my first point, this, I'm not going to worry about that one up there at positive 2. This is going to move right here. Okay. This point has to move 2 tick marks, 1, 2, over. Okay, this one is going to move 2 tick marks, so it's going to go right here. And then this is going to move 2 tick marks as well, so it's going to be right there. And so we need to actually figure out what the values are at this tick mark, at this tick mark, and at that tick mark. So you can count by pi over 12. So this is 1 pi over 12, 2 pi over 12, 3 pi over 12. So this is going to be 4 pi over 12, which is pi over 3. So this is 5 pi over 12, 6 pi over 12. This is going to be 7 pi over 12. This is 8 pi over 12, 9 pi over 12. This is 10 pi over 12. And so now we have all those points that we needed. We are going to have to continue this on, right? Because we're supposed to go all the way out to 2 pi. So we get all of these out here, but we don't need to label the rest of these. But I can follow the pattern, and if you look, each blue tick mark, or blue dot, is 1, 2, 3 tick marks away. So I can just carry on the pattern by saying from here, I go 1, 2, 3, and there's a tick mark. There we go, my point. 1, 2, 3. I'm down here at negative 2. 1, 2, 3. 1, 2, 3. Oops, too high. There we go. And 1, 2, well, we would be all the way out here somewhere. Okay, so now I'm ready to actually draw this in. So we start here. I think I do this better if I go faster. Okay, maybe not. Okay, I'm going to stop right there at 2 pi. And then I know that this needs to carry on all the way to 0, which, who knows, goes somewhere like that. All right, so you can imagine how complicated this can get when your denominators don't fit. Now, another way that you could have thought about this had you wanted to, you still have to get the pi over 12, the pi over 3, the 7 pi over 12, and the 5 pi over 6. But you could just actually calculate out by hand, take pi over 4 and subtract pi over 6. So if you do that math, just do it in your head or do it on a piece of paper or something, you'll subtract those and you get pi over 12. Same thing is if you took, pi over 2 and subtracted pi over 6, you're going to get pi over 3. So you can get those values. You just wouldn't know exactly how far over relative to the pi over 4 you should move. Okay, there we go. Hopefully you don't have too many of those, right? All right, next. Now, here's a question for you. Sometimes they just give you the equation and you just need to figure out the three things that they're asking for, the amplitude, period, and phase shift. Well, the amplitude's pretty easy to figure out. Amplitude is going to be 4. Okay, period, well, there's your 2, right? So you're going to do 2 pi over 2, so the period is pi. Phase shift, you got to be careful. A lot of people would look at this and they would say, oh, the phase shift is pi over 3 units or radians to the left. But that would be wrong because this 2 is inside the parentheses. And so there is a distinction there. What you have to do is actually factor out that 2. So it's y equals 4 times the sine of 2 times the quantity of x plus pi over 6. Okay, so now we can say that the phase shift is pi over 6 radians to the left. So be careful about that. Next, you are going to have some problems. We did these before, where they give you the amplitude, period, and phase shift, and you have to come up with the equation. Okay, so amplitude should be fairly straightforward. Period, hopefully, is also straightforward. We've done that before. Phase shift, well, that should also be pretty straightforward. You have pi over 3 radians to the right, so we know that that pi over 3 is going to take the place of c. To the right means that we're going to have a minus instead of a plus. And 1 unit down, that's the 1, is going to be the d. And it's going to be a minus because that's a direct movement. So our first equation is going to be y equals 3 times the sine of 3 times the quantity, or of the quantity, x minus pi over 3, and then subtract 1. And now we just have to do all the combinations of plus and minus, right? So let's do the negative of a. And then when we change this positive 3 to a negative 3, we have to put our brackets around this, okay, so that it doesn't look like we're taking sine minus that quantity. And then, of course, there's the last one. Remember, always going to have 4 answers. All right, hope I didn't blow your minds. Good luck, folks.